Welcome back to MSM2 and this is Frazier. How's everybody doing? If you would please make sure that you're checking in with your advisor. I am going to start today's lesson. We are talking about classifying quadrilaterals. So what's a quadrilateral? If we break the word down, quad meaning four. So it is a four-sided polygon. Quadrilaterals are just one of many polygons. Polygons are many-sided figures. So that is a broad term. Poly meaning many. So many-sided figure. It has to be simple, flat, and closed. So what do those things mean? Number one, it's simple, meaning that you don't have any intersecting lines. Closed, well, this one's not closed because this segment does not touch this segment. And it needs to be flat, two-dimensional. It needs to be made of segments. The word segment over here, this one is not a polygon because it's not made of segments. Over here we have examples of things that are polygons. They're all flat, they're all simple, there's no intersecting or overlapping lines, there's no sections where it looks like it's two shapes sort of meshed into one, and they are all closed. You have two categories in the polygon side, convex and concave. Now, convex is sort of what you've been doing most of your educational career. Most shapes that we look at are convex. So let's look at the concave side. On concave polygons, you have an area where it is caved in. So anytime that you have one of the vertices, one of the corners, that's sort of caved into the shape, you would call it a concave shape. It only needs one corner, one vertex, to be caved in, so to speak, in order for the whole shape to be called concave. Kind of like a triangle only needs one right angle to be a right triangle, or an obtuse triangle only needs one obtuse angle. Same with concave. So if we look at the words, simple, meaning that there are no intersecting segments, and intersecting just means crossing. What does closed mean? Closed mean that it is not open, which seems really to make a lot of sense, but it means that all of the segments connect at a vertex. And concave versus convex. On a concave, one or more vertex is caved in. We'll put it in quotes. So one or more vertices, plural. One or more vertices are caved in on a concave polygon. None on convex. If you're thinking about language arts, if you're doing how are they the same, how are they different, you'd want to make sure that you talk about both of the shapes. In a regular polygon, and this is a new vocabulary word, regular polygon, all of the segments have to be the same length, and all of the angles have to be the same measure. So some regular polygons that we're familiar with. The first one that usually comes to mind is the regular octagon for a stop sign. All of the segments are the same, all of the angles are the same. So a regular octagon would be a stop sign. Also things like squares, equilateral triangles, and all kinds of other shapes can be regular. You can have a regular hexagon as long as it has 6 sides that are all the same and 6 angles that are all the same. We have a variety of names of polygons here. They all have a prefix that matches the number of sides. So triangle meaning 3 sides, quadrilateral meaning 4 sides, and down the line. So prefix meaning that starting, that opening piece of the word, oct, non, dec. So sketching a regular hexagon means you need to first know that a hexagon has 6 sides. So if I want a regular hexagon, I want it to have 6 sides that are all the same length, and I want it to have 6 angles that are all the same. So I would use the single tick mark to signify that all of the sides are supposed to be the same, and a single arc to signify that all of the angles should be the same. So that's our regular hexagon. And a hexagon that's not regular might be something that's kind of stretched out where, yeah, okay, so there's some sides that are the same, but not all of them. Sure, there's some angles that are the same, but not all of them. So this is a hexagon that is not a regular hexagon. Lots of options for that. It could also be a concave hexagon. That has 6 sides, but not all 6 sides are the same. Not all 6 angles are the same. So other options for non-regular hexagons. And if you flip it over and take a look at the back, we have a diagram with all of these quadrilateral options. They're all quadrilaterals because they all have 4 sides. And they are classified based on their side lengths, their angles, and if they have any parallel sides, if they have any perpendicular sides, things like that. So we have a symbol for parallel sides. That's the little arrowheads. If they have the same number of arrowheads, then they are parallel. So the top of the rectangle is parallel to the bottom of the rectangle because they both have 2 arrowheads. The tick mark, meaning this little dash, if it's 1 tick mark here and 1 tick mark here, they are both the same length. The left and right sides have 2 tick marks. They are the same length as each other, but not the first sides that I showed. 1 arrowhead and 1 arrowhead means those sides are parallel, but not parallel to the first 2 sides. Last symbol we have is the little square in the corner for a right angle. That tells us if something has a 90-degree angle. Squares require 90-degree angles. Rectangles require 90-degree angles. Trapezoids can have 90-degree angles, but it's not required. So 3 symbols to take notice of there. Some people like to use highlighters to help them. So if you want to measure, or if you want to say that like these 2 sides are congruent, you might mark them with the same color. You might also mark the top and the bottom with matching colors because they are congruent. Sometimes that visual helps. On the trapezoids especially, the trapezoids only have the 1 pair of parallel sides, so it's really helpful to identify which pair are the parallel sides on a trapezoid. So you might have this and this as marked so that you know that the trapezoid just has the 1 pair. So if you go down to the bottom, your notes are already all filled in. What are the qualities of a rectangle, parallelogram, and so on? You should be able to read that part. At this stage, if you wanted to shut the video off and read the rest of the notes, you can. Otherwise, if you prefer listening to it, please feel free to stick around. What is the defining characteristic of the quadrilateral below? What does a rectangle need to have to be a rectangle? It needs to have 2 pairs of opposite, congruent, and parallel sides. So you will notice opposite means like one's on the top, one's on the bottom, or one's on the left, one's on the right. The ones that are opposite need to be the same length, and they need to be parallel. And because it's a rectangle, all 4 angles need to be 90 degrees. Parallelograms. Parallelograms are a little bit simpler. They don't require the 90-degree angle, but everything else is the same from the rectangle. So opposite, congruent, and parallel sides. So the only difference between the rectangle and the parallelogram is that the rectangle requires the 90-degree angles, parallelogram does not. So if it's a rectangle, it is also a parallelogram, parallelogram being the less specific name for the shape. Square. Square has to have 2 pairs of opposite, parallel sides. But on a square, all 4 of the angles are 90 degrees, so all 4 angles congruent, and all 4 sides congruent. So not just the opposite ones congruent, all 4 congruent. Rhombus. Rhombus, if you look back up the picture, also says rhombi. Rhombus being the singular if you only have 1 of them. Rhombi is the plural if you have more than 1. 2 pairs of opposite parallel sides. And those 2 pairs of opposite parallel sides have to have also opposite congruent angles. So I'll draw this over here. So opposite sides have to be parallel. Opposite sides also have to be congruent. Opposite angles also have to be congruent. So those are the same, and then these are the same. But you'll notice not all 4 of the angles the same. The last thing is that all four sides are the same. All four sides congruent. So if I just zoom this in a little bit so you can see the one that I just drew, I would have to put not only the arrowheads, but I would also have to fit in there the tick marks. So this side, this side, this side, and this side also all congruent. Gets a little tight, so if you look back up here, you can see the rhombus up here has the arrowheads for parallel, has the tick marks. What it's missing are those angles, that this angle and this angle have to be the same, this angle and this angle have to be the same. So rhombus is sort of like a square that has tipped over, if that helps. Last two, the kite. The kite has exactly two pairs of adjacent sides congruent. Now you have to know what the word adjacent means. Adjacent means that the sides are next to each other. So adjacent sides congruent. So on the kite, these two sides are the same length, and then these two sides are the same length, and what do you know? It looks like a kite. Last but not least, trapezoid has exactly one pair of parallel sides, not both. It's kind of the odd duck there, where only exactly one pair of parallel sides. So trapezoid, if you look back up the picture, can have the parallel sides on the left and the right. It might also have the parallel sides on the top and the bottom. This one is called a right trapezoid because the angles here are both right angles. This one is called an isosceles trapezoid because the two sides connecting those parallel bases are the same length. So the one tick mark here and here makes it an isosceles trapezoid. All right, so hopefully we're in good shape for the naming of quadrilaterals. If you have any questions, don't forget about finding the time when your teacher is available for a video conference or email. Make sure that you've got your notes out or your homework when you go in to ask any questions, that you have something to show us or that you have a question ready to go. Really helpful to make sure that we have time for everyone. So I hope you guys had a good day today. Please make sure to be in touch with your advisors as needed, and we'll see you for the next video. Bye.